around 9+ years of experience
Yeah.
and into performance testing. And also I usually work with the clients, and I work with mostly non-functional requirements. I also work for the ROI team within my company Cognizant, where we work on various tools which are emerging in the market, which is really helpful for the clients or and to keep up with the market and the trends. And today, my topic is on the Kiosk Blade tool, basically, which is which follows this chaos engineering part, where we will talk about how what exactly the chaos engineering is, and on a high level what the chaos blade tool is, and also I'll walk through the chaos blade installation and connecting the experiments through various modes. And also the finally will look after some of the experiments where we can carry out. Chaos blade is a very vast tool kind of thing, so you have a very huge number of experiments. It's not possible to cover everything, but I'll try to cover at least few in this walkthrough session, in this workshop basically. And next, coming to the chaos engineering on a high level, chaos engineering, it's nothing but basically to keep resilient. I mean, how resilient your cloud is, and nowadays everybody is moving to the cloud. And what happens if one or the other fault injection or one or the other fault has been identified in the in the production? So and also the chaos experiments or the engineering part, we definitely work in a disciplined approach. It's not like the other types of functional or the non-functional testings where we increase the load or we do any random test kind of thing. And it will be completely done in a controlled environment. And we observe how the cloud systems or how the systems are going to respond because of this unexpected or the fault events. And we are going to further analysis what kind of errors we have seen, or whether the application is working during that stage or not. And we'll try to make resilient that. And and next, with respect to the coming to the benefits of chaos engineering, so improved system resilience, as I mentioned earlier. So, what happens if the control failures are seen, and how do we really identify? Will really identify at the earliest stage itself, and will also work on the. I mean, it also helps on the reducing the downtime. And it increases the confidence for the project team or the client, saying that so we have done so many so and so experiments. And unlike the other testing types, we don't consider, we don't say over here as test cases or test scenarios. We, in fact, call them as an experiment, because we wantedly try to inject the faults into the system, and which also reduce the cost with respect to the outages. So rather than facing errors in the production, it's good to go ahead, good to see errors in the test environment itself. And also some of the times the fault injections or the chaos engineering will be performed even in the production environment, to see how the production environment is going to behave when there is a huge load, and what if one of the pods goes down. And the basic we should be following a few principles like the other types of testing. So we have the scope should be very definitive. We have to be very careful what we are going to define, because if we just keep on we basically bring down the pods or the containers, and also the CPUs will be burnt. So during that time, we should not see any outages, or it should not, end of the day, it should not affect our work or the customers basically. And And also we have to start with this small experiments. We should start with the small, and we should be increasing gradually. It's not like will be increasing the cpu utilization all of a sudden to 100% or 90% by within a second or 2 seconds. So initially we can check for at least 10 seconds of interval, and right after that we can go over with 2 minutes or 3 minutes based on our requirements. And also we can most of the experiments that we are going to see over here using any of the tools, it will be basically the automated ones. So we can automate the experiment, and also we can run through the command line, we can run through the API calls. And also during this experiments we have to basically monitor what exactly happening at the infrastructure level. And next, with this, I'm going to conclude the basics of the chaos engineering. Let's jump to the chaos blade tool, which is, this is a tool I'm going to cover throughout the workshop over here. And basically, Chaos Blade tool, it's a kind of cloud native chaos engineering platform, which also supports the bare metal, and also the Kubernetes, Docker, and the clouds. So yeah, and also we can perform the experiments via UI interfaces, and also it supports and also to my knowledge, Chaos Blade is one of the tool which supports majority of the Chaos experiments which are present in the market, and which is an open source. And also the Chaos Blade, it was developed by Alibaba, which is a internal tool for the Alibaba cloud testing. Because of the capabilities of the cloud, it has been released to the market, and which is very helpful for us. And also, the next thing is on the Chaos Blade. So these are the different what do you call the tools we have in the market, and Chaos Blade is over here. And also, if we see over here, Chaos Blade marks many of the ticks over here, and also it is marked as a GUI as doesn't available, but still we have the GUI part where we can do the things. And compared to the over here, it supports the applications, the physical host, or the host machine basically, and also the containers and the pods. Also, the reliability scoring over here, it has given us. It is not given over here, but the alternate way is that we can basically mark within the tool that whether the experiment has been proceeded successfully or not, whether it is up to the marks or not. And also, the one more benefit over here is that it's an open source. It works with we can execute the experiments through GUI client, the terminal mode, and also through the API calls, and also through the YAML files, where we can just do the kubectl apply if, and we can apply these things. And also the we don't have the health checks over here. And coming to the cons part over here. It's good if anybody understands the Chinese language, so it is very useful, because the most of the document, I could say around 60% of the documentation is in Chinese. So whenever I read, I just convert that line into the English language, and I try to understand. And also the basic things it lacks is on the scheduling part and the reporting capabilities, unlike the other tools, other commercial tools or the open source tools. And regarding the scheduling, we also have we can define upfront, like it has to run for every 3 hours or 4 hours. Even that option is available for the Chaos Blade tool over here. And next, we'll look on a high level on the Chaos Blade architecture over here. So the Chaos Blade first thing will comes as the Chaos Blade box console, where which is a user interface, which is an UI, and it basically has the Chaos Blade box server in the backend where it tries to communicate, and finally it reaches the target through the agent part. And also Chaos Blade also supports litmus tool over here. And also basically the Chaos Blade it is originally originated as kind of orchestration tool actual testing tool. But later on, even the tool has been even the experiments can be carried out over here. And on next, coming to the components, as I mentioned earlier, the box console and the box server, and the agent, which has to be installed on every host machine and also on the clusters, so that it will be able to transfer the data to the actual tool. And also we have the Chaos Blade execution tool. Chaos Blade execution tool is nothing but kind of an experiment performing tool, where we can run the experiments based on the requirements. And I'll just, on a high level, I'll go through the Chaos Blade box, and following with that, we can look after the installation, and followed by the experiments. And please do let me know if there are any queries at this point of time.
Shravan, just one thing. Could you please enlarge the slide, as in if you can put it on the presentation mode?
Yeah,
Thank you.
sure. So, so this is our Alibaba Kiosk Blade tool. This is the user interface. Somehow it's locked out. So this is our overview page, where it shows how many drills or how many experiments we have conducted so far. And over here, if you could see, I've conducted around 11 experiments, and out of which 3 were success and 8 were failed, because I wantedly did it fail. So, and also you can see that over here we can see that there are probes. Probes are nothing but the agents basically. So the agents, we have one host agent or one host probe, and also one cluster probe over here, and both of them are online. And also the exercise log. So I have carried out a few of the experiments within the same host machine, and you could see over here I've started creating the experiments or running the experiments from 11th of November. So on a high level, it shows us at which date and which day we have run, how many experiments were carried out, and also some of the practice scenarios it will go through, and also what are the component types that we can carry out, whether it is application or the operating system or the container service over here. And the my over here we have this one option over here, which is default and add environment. So once we click on add environment, the experiments that we are carrying out over here, and in the default, or we can create multiple environments which can clearly differentiate be it the production related experiments or the test related experiments. We can basically segregate this over here once we add the environment. And also the next thing is on the MySpace. So this is one of the important UI phase over here, which shows the list of experiments that we have carried out over here. And also we can start creating the experiments from here using this either from blank walkthrough or from the experience base. And the next part is on the rehearsal scene. So in case if we are not aware of what to check or what to test and from where to start, so Kiosk Blade tool gives us various options over here, either through Kubernetes or the host. So if we go through the Kubernetes, we can work on the we can carry out the experiments like node, CPU, container, pod, the various types of resources we have over here. And also the experience. Basically, we can add some libraries over here. Currently, I'm not working on this, so I'm not very clear on this. And also the application management. Uh, so where this is the place where we have, see, let's say we have around 2 clusters or 3 clusters. What are the clusters we have added to the environment? All those applications that are available in those clusters that can be seen over here under the application management. If you could see over here, there are lots of Kubernetes related applications. So most of them are related to my applications, and also the Kiosk default app that I've installed on a host machine. So that also shows over here. And if I go through each and every tile over here, we can see the basic information of the application over here, and what is the machine that is being used. It's our cluster IP, one of the cluster IPs, the Google Cloud cluster IPs. And also, this is the exercise records that we have performed. Any if there are any drills performed, so that can be seen over here. And also the application configuration, what kind of application it is, K8s and Java space, Java, and also the namespace that we can see over here. And yeah, so this is about the application management. So what are the number of applications hosted on the clusters and where we install the agent. The agent will collect all of those information and will be sent to the kiosk plane. And also coming to the coming to the probe management. So far I have one host machine added and one Kubernetes cluster that I've added, and this is the cluster IP, and this is my device ID. And so over here, if we can either run the experiments through the Kiosk Blade actual Kiosk Blade experiments tool, or through the Litmus kiosk. So currently I'm working only with the kiosk blade, not with the Litmus kiosk. Yeah, and some experience management, so where we can create some kind of templates upfront, saying that this are the things which I'm going to work on, or which we are going to work on. And finally, yeah, so the data migration part, currently I'm not working on it. So on a high level, this is the overview of the Chaos Blade box user interface over here. And so let's start with the installation part. And also the Chaos Blade Chaos Blade. So the Chaos Blade box can be installed on the host and also on the Kubernetes machine. So if we are using, and also the major con I could say is the Kiosk Blade doesn't support the Windows related things. It only supports the Linux based operating system. So if you're working on Windows laptop, so if you have a Minikube installed, that will be easy for us to download or to carry out at least the basic experiments, or we can start practicing on that. And for the host installation, these are the dependencies: the Java 8 version, Java 1. JDK 1.8, Ansible, Expect, and also MySQL 5.6. So over here, it works only with the MySQL 5.6. I don't think it is updated yet. So I have basically tried with the latest version. So I'm not even able to launch the tool basically. So the connectivity part is not happening over here with MySQL 5.6. So for this, Chaos Blade had given us the Docker libraries where Docker files or the Docker command, or and so we can basically pull the MySQL 5.6 from the Docker hub, and we can install that, and we can carry out our activities. So firstly, I'll go with the Chaos Blade box installation. So this is my VM over here, the Google Cloud VM. So basically, if we could see the Java versions over here, Java version is JDK 1.8 OpenJDK, and also the expect version, yeah, expect version, and also we have I have installed Ansible. Okay, I think I'm giving some command wrong, but basically it shows that Ansible has been or has already been installed, and so let's start with the installation command, starting from the the box installation. So firstly, let's get the box downloaded over here. Chaos Blade. So they have, I mean, majorly will have find all the details in the Chaos Blade GitHub, and also they have one documentation, Chaos Blade documentation directly on the .io. And if you could see, there are so many various tools or the options or the repositories basically we have over here to download or to proceed. First, let's go ahead with the Chaos Blade box. So it is saying to run this Docker run command. So let's create this Docker. So it has already downloaded and it started working. So firstly, we'll download the Chaos Blade box, and then we can run through the installation part. So and the next step over here is to run this command where to run the Java command to download the jar file. Let me download the jar file first. So, with respect to 103, I don't know, somehow I'm not comfortable with the 103. Probably I got habituated with 102. So, I'm going ahead with 102 alone. If anybody has the Docker available in your system, you guys can install along with me. So, which is very easy to do the process. So, I have this jar over here, and now I'm going to run the actual hub command. Hope my screen is visible over here. So over here, we are going to get in touch with the Docker that has been already installed. So if you could see over here, the port already has been opened and it is already forwarded to the 3306. So we are going to use the same port over here. And also we're going to use the Kiosk Blade box 102.jar, and also I'm giving over here the username as root and the password as the kiosk blade, and over here I need to give the host or the machine name over here. In case in case if you want, we can also give the direct cloud name over here. Even that will work out. So this has already given us the process ID. Let's find if it has been installed or not. Yes, it throws me this thing. Yeah. It is running on 1.3.5. So it has given the process ID, and here is the process ID that is working, and also to check whether what are the logs that are available. If we wherever we run this jar file, so over there we'll have this kiosk date box .log. So if there are any errors, we can get into this box.log and dig down, drill down what exactly the error is. So far I don't think it has given me any errors basically. So it is now what it does is that it will try to download all the related files, and it will basically insert or create a database on its own within the MySQL. In some Now let's see what kind of database tables it has done so far. So let's in order to dig into the tables database, we need to interact with the Docker container over here. So let's see what the ID or the image ID, basically the container ID for this MySQL. This is our container ID. So in order to interact with the container ID, we have a command to execute. So let me just copy. So this is the Docker command which executes interactive mode with the Docker container through the bash. So now we are into the Docker container. If we just give ls, so it throws the, or it gives the holders of the container. And and in order to get into the MySQL, we can interact with the command line as well. So for that, we have one more command, which is MySQL MySQL connect command. Since we are giving the password over there, let me just give -p over here, which prompts for the password. I've given the password as Chaos Blade over here. And now we are into the MySQL terminal. And if we just ask show databases over here, it will create the Chaos Blade schema over here, and we can use the schema to check what exactly is there in the. So the Chaos Blade jar file have created all these tables right now to start with the execution. And now let's launch the UI part over here. Uh, so for that, the command which I've given over here is given it as a localhost 7001 as my port. So let's launch with the same. And this gives our so since we're coming, I mean, since we're launching for the first time in the system, we need to sign up for the credentials over here, this username and password. So in this way, we install the Chaos Blade tool in the system or on the host. So the same thing can be performed on the Kubernetes as well. So in my Windows system, I have installed Minikube over here. Let me just run that Minikube start. So right now the Minikube is being started. Please give me 1 minute. So meanwhile, I'll just go to the Google Cloud that I've installed so far. Yeah. So as part of the testing purpose, I've dumped or downloaded the microservices based application. So This is a application that I've used for testing. So either in order to use this the microservices application, either we can directly click on open in Google Cloud Shell. So what happens is that it will download and install on your Google Cloud directly, and also by default it works on the autopilot mode, not the standard mode. So there are two types of GKs, global cluster, Google Kubernetes engine. So one is through the standard mode, and the other one is the autopilot mode. Basically, what happens is that through the autopilot mode, it doesn't get too much of hands-on on that. So there will be restriction for each and everything. So I have used Google Standard Cloud over here. So this is one of the cluster that I've created with 12 CPUs and total of 48 GB memory, and with 3 nodes. And I have installed or I've downloaded the application. So let me just go through this demo app. Yeah. So these are the services that are available in the microservices demo. So I'm going to use a few of them today. And let's see where this mini cube is. So I think, yeah, it already started the mini cube. So let me just see if my kubectl is going to work over here. So these are the pods currently running in the system. So in order to start with the Chaos Blade running on a Kubernetes as a pod, so firstly let's create the namespace for that. NS is nothing but the namespace over here, and so there is a Chaos Blade namespace that has been created, and now in order to run the Kubernetes, I mean, in order to run the Chaos Blade as a pod, we have to download dependency file, the software. Basically. So for that, we have to use this Chaosblade box 102.tgz. So it has all the manifest files and also the YAML files that are really required uh, for the Chaosblade box. So I already have downloaded it once. So I'm going to leverage the same thing. And we are going to use Helm as a command over here to install or to run this Chaosblade box. So over here, we are going to use Helm command, Helm install Chaosblade box, and the version over here. And also, it is going to install on the namespace as Chaosblade. and we are setting the password for the. So even over here, since it should it needs the MySQL 5.6, so it will download automatically from the Docker Hub as a container, and it will work on, it will run over here. So let's run this command. So it says that Chaos Blade box. So it is success. Let's see. So now, if you could see, both the things are running over here, and earlier we don't even have these pods running over here. So it's a success. Now, since the pods are running within the Kubernetes, if we want to access, then we need to do the port forwarding for this thing. So let's get the services that are available. So over here, this is the load balancer IP that we're going to navigate, and it is working on the port 7001. So let's do the port forwarding for this. So I'm giving the same IP as 7001. We can change if we want over here, and I'm writing the support forward over here in order to get that user interface available. So now you could see that it has been forwarded from the Kubernetes host to the local host, and I think now it should be accessible ideally. Please give it a minute because I don't think it has started running in the backend. I think it will need a couple of minutes to bring up completely. No, let's give it some more time. So I think because my CPU is overclocking, I guess. No, we'll revisit again after a few minutes. So I think its connection has been refused. Let's give it a few more minutes. And meanwhile, so next thing is let's work on the Kiosk Blade probe installation. So we see over here, if we go to the probe management, we have two things. One is the host and the Kubernetes. So let's first try to run the host part over here. So I have tried installing through automatically install probes. I don't know, some reason it's never been successful for me. So I always go with the manually install probes and under this host. So we'll be given with the command over here, and we can use this for this thing, copy command, and let's modify to our needs. So localhost 7001, and the port we can give any random port over here. I'm giving 8099, and the application group, I'm just giving test application group, this group over here. So basically, these are the groups that we were seeing earlier within the application, basically. So if you see over here, um, so over here in the probe management and in the application management, the group names, application type, and the machine grouping, all these things. So these are the things that we're going to give over here. And the application name, as I'm just giving it as test application name. And I think that's it for now. So let's go and run the system. So basically, it is downloading the Kiosk probe file or the agent file from the server, and then it starts extracting and installing. Permission denied. So let's go to the Kiosk. I don't know, for some reason it is not writing into this, but it usually writes into the OPT folder. Let me just give one more try. Yeah, I think that is some permissions issue. Uh, Now it is installed. Let's see. Yeah, so this is the my machine name is instance 2 over here. So this is the probe that has been installed for the host machine, and the test application, that is the name I have given, and the application overview. So this is one of the host, one of the application, one of the hosts that has been added. Now let's try adding the Kubernetes host. So in order to install the Kubernetes host, as I mentioned earlier, I'm never been successful even for this Kubernetes host. Let's do it manually. And I have a cluster that is available that I can really install and show you guys. So yeah, so this is one of the cluster that I have. Let me just take the terminal this cluster. I think I'm taking the wrong. So this is one of my other cluster where I have around 4 nodes and 64 GB of memory and 16 CPUs. Let me connect with this. No, somehow the status is still fetching the data. Okay, in this we don't have that. I think I got deleted. Let me just download this uh, microservices demo as well. Yeah. So sorry guys, let me just go back to this thing. So we were trying to access the cube CTL, I mean from the mini cube thing. So now if you could see, the port forward has been working fine, is working fine now, and the process has been successful. So we are able to see the dashboard and this stuff. Yeah. So this is the local host one that I've installed on the Kubernetes on my Windows laptop. So it is working fine now. And if you could see, these are the previous experiments that I've executed within the mini queue. In this way, we can also use the Chaos Blade tool in the Windows machine for the practice purpose at least, or even in the production for the testing purpose also we can use it in the directly install in the clusters instead of taking a host machine like me and then installing over there. So let me just stop the mini cube over here. It is taking a lot of my system resources. If you have just one, I mean, if you just have only one Chaos Blade running, I mean, only Chaos Blade pods are running in the system, that is fine. Since I have many pods that are running in the backend, which is throwing me error over here. I mean, my system has become very slow, so that's the reason I'm stopping these things now. Okay, and let's run the, so we have connected to the Kubernetes cluster over here, and let's run the microservices demo over here. So I think I should have the microservices. Yeah, I already have the microservices over here. Releases, and let's yeah. So we are going to apply this YAML file. So it will dump. I mean, it will basically up every pod that we have. So command to that kubectl apply f, and before that we'll just check the namespaces. So the demo app is I don't want to use it now. I'll just delete and recreate it. I don't want any mess. Yeah, let me create the namespace again. And let me just find this. So over here, I'm so sorry if the font is very small. So over here, I'm applying the YAML file over here, and I'm using the demo app as a namespace to load the pods. And over here, it says all the pods have been created. Let's see the status of those pods. So over here, PO is nothing but the pods over here, the short form of pods. And if we see everything is running, but these are running as a zero and one, zero instances of pods, zero pods are running. So we have to wait for a couple of minutes to come up, bring this up. Only one is pending. Yeah, I think now all the pods are running. So if we go into the workloads, we can see the list of pods that are running over here. And now over here, we have to install the Chaos Blade box agent over here in order to communicate and pull all these microservices or the pods to the Chaos Blade tool. Split box basically. So first we'll do this wget. Oh, it's not here. Yeah, just a box that is available over here. I'm just going to paste the command. So we are basically trying to download the box agent over here and renaming it to chaos.tar file. Yes, chaos.tgz, which is powerful. And now I'm going to install through the helm command once again. And over here, this is the command to install. So let me just break down these things. And in this, the chaos plate chaos.tgz is a file that we have downloaded now. And this is a namespace. And the environment name, I'm giving it as a default. I don't want to create anything now. So the one which I mentioned earlier over here. So if we have the different environment, we can add a new environment and we can give the name over here. And the license is the default one that comes with the installation of the box. And this is the repository, and we have to give the transport endpoint over here. So it is asking me replace with the IP and port of the box. So I'm simply giving now I need to take the IP address of the Chaos Blade box over here. So for that, let me go to Google Cloud. And I have these are the four nodes basically, and this is my instance where I have where I'm running the Chaos Blade box. So I'll just give the this internal IP. I think that should be fine for me now. And the box is running on the port 7001. So I'm going to give that IP, and the cluster ID I'll just give it cluster 001 to identify it easily. And the cluster name, I'm giving it as Kubernetes. And I think now we're good to execute the command. Yeah, probably I did not create the namespace. Let me just, yeah, just let namespace is not available. Let me create a new namespace. I'm running the command again now. It says that the box has been installed successfully. Let's check on the checking the box, first blade box, if the probes are up and running. So yeah, this is the cluster 001 that we have created, and the name we have given it as Kubernetes. And over here, if we go through the application, we just got only the Kiosk Blade application. Let's wait for a couple of minutes to get the other tools as well, the microservices as well. Now we have to install the Kiosk Blade operator, so which is useful to down to perform the experiments. Yeah, so it had brought up all these application microservices that are available in the cluster. Now let's see the installation of the Blade operator. So right now, what is happening is that the Chaos Blade, the agent that we have installed on the Kubernetes, so that just acts as an agent and it pulls the data from Kubernetes to the Chaos Blade box. However, if we want to perform any experiments, so we need the operator to be available in the Kubernetes cluster. So let's work on the operator. So if we go through over here, we'll have this circular split operator. And if we see the releases, and the latest version is 173, but I have observed that there are few bugs in between these, and which is stopping me the stopping my work. So I'm going with 1.5 150 over here, and I'm just copying the link and downloading it to the cluster. So over here we have this Circus Blade operator, and we have to install this Circus Blade operator through the help command. Here is the help command, helm install, and the Chaos Blade operator, and the final namespace. There's nothing much huge in the command, but it is useful for the to perform the experiments. Yeah. So let's see if it is running. Yeah, so the operator and the tool, these are related to that. So all the things are running for now. And let's start with the, let's go ahead with the experiments part. So first we'll go ahead with the node related experiment first. So over here we have around four nodes. We totally have four nodes over here. Let's start with the node level experiment. First thing I'm going to do is that I'll increase the node CPU utilization. So for that, we can either go through the rehearsal scene over here, which is through the node CPU full load, or we can go through the MySpace. We can just start it from the new blank through. And over here, I don't want any application. Basically, it's a non-application. I'm just trying to access the Kubernetes over here. And once we click on Add Walkthrough, we can catch this node CPU full load. Click on Confirm. And once we click on over here, so there are multiple options which comes up over here. So we are going to give the CPU percentage as some 40 percentage of utilization for that, and the name. So the mandatory fields are over here. The basically the pod name or the node, since we are doing with the node names, node CPU full load. So let's go ahead with the node name over here. Sorry. So let's go with this 2MZN. Now this node second node. And I'm going to give the name as the node name, and I'm going to give the CPU percentage as 40%, and click on close. Now, basically we can do multiple experiments within the, we can add multiple experiments within the same configuration, same walkthrough. So I'm going to add the CPU utilization as well over here. Sorry, the memory utilization, the node memory load, confirm, and select the node memory over here. And so I'm just going to give it as 60%, and rest all for now they're not needed. Over here I need to give the node name, so that node ID, so that it will perform on this node. And finally, yeah, that's it for now. And click on save. So once we save, we're going to go in the next step. So there are two parts over here. One is the sequential execution and the stage execution. If we do the, if we go ahead with the stage execution, so the CPU and the full load are going to perform, CPU and the memory load are going to perform in parallel. So currently I don't want my thing to be going on in that way. I don't know what exactly happens if both of them goes high, and if the server goes down, it's too tough to bring it up again for me in the workshop. So I'll just give it as 8 minutes over here. And earlier I was telling you guys about the schedule part. Since we don't have any scheduler over here, we can configure basically for every 1 hour or day or week. And when we want to exactly execute, right now I'm not going to configure anything. I just wanted to run it once. And and the experiment is going to run for 8 minutes. Around we can consider everything together 10 minutes to the max for each and every load over here. So finally I've saved it. And so if you see some of the places, even in the application we have this Chinese written over here, but if we hope we'll get it in English to read through. And click on the drill over here, or else if we go to my space over here, this is the test node GTR that I've created, and I can click on drill over here. And since I've added the two nodes over here and two scenes, basically it is showing me two nodes over here. If I'm running only for pod one pod, so it is going to show me the pod file over here, and pod over here. And right now I'm clicking on drill. So drill is nothing but the experiment over here. So if we go into this, we can actually watch what is happening. So first, the node CPU full load is going to get triggered, and so right now this scene has been successful, which means that further it is going to execute. And to get confirmation on this thing, if we click on this machine option, it says as it throws us the basically the status of that particular thing. So kind is node related, and this is the ID that is given us, and it has the state is successful now. So it is going to perform experiments further. So for this we have to monitor what is whether it is whether the CPU load has been is being applied or not. So I've created just a couple of dashboards over here to showcase or to observe the things. Uh, Deepthi or Mehak, can somebody confirm how much time still left for me? Do I still have the time or? Hello, Mehak or Deep Deepthi? Am I audible?
Yes, you are audible.
Yes, yes, yes.
Yeah.
Yes, Sravan.
And let's go to the monitoring tab over here. Okay, I think it is showing me only the previous ones. Yeah. So now my time over here is 12:58. I stay in UK, so the time is different over here. But if you could see, there is a hike in the CPU utilization and also in the memory utilization over here. And this thing, the memory utilization is still up over here, and I think the experiment got completed. Is that it is not still running. It is still executing. So it's gonna take a couple of minutes. So meanwhile, I'm going to show you guys on the API thing. So how we are going to get these details via API. So let's check the status of this via API calls. So this is the API that we can really use. Uh, No, this is not going to work over here. So sorry. So until it runs in the backend. So let me just show you guys on the command line tool how we can use or execute the commands. I mean, how we can hide the CPU utilization through the command prompt or the terminal. I think I only have 10 minutes, so let me just quickly
Yeah.
show you guys.
Quick time check, Shravan. We have 10 more minutes.
Yeah, sure thing.
Thank you.
So over here, if you guys see, I have this. Sorry. Somehow I'm not able to access it. Why? So this is the agent whatever we installed earlier. So that will that will be installed in OPT folder. So over here, if we see there is a blade option that is available, which is called so which is useful for to trigger the experiments over here. So let's see the blade status over here. So it says success false less parameter. Okay. Yeah. Anyways, the status command is useful to check the status of the. If let's say if we have executed any experiments, it shows the status of that. So let's quickly run that statement. Yeah. So we can run the command. So this is one of the command which increases the CPU utilization of the of this host. So if we want the similar thing to be done in the chaos blade operator, we can make it as instead of just CPU percentage, we can give K8 and also the node name to increase the CPU utilization to view the CPU utilization. So currently it is showing a success and it is giving us the ID, one ID. So this is useful for us to check the status of this, what is happening in the backend. So let's check in the system monitor and I've given 60 percentage and right now the CPU is clocking at around 60% to 65% in all the codes. And let's check in the status. So over here, if we want to check the status in the API, we can give a status command. Yep. So over here, it is saying that CPU flag and also full load, and it is the success is true. So when it has executed or the updated, and also if we check on the top command, it shows us the chaos burn CPU, which is a command line that is being executed. So let me just destroy. In order to destroy this, we can use destroy command over here. Instead of status, we can just give destroy. So what happens is that it will bring down the chaos that burn CPU, and the success is true. Now, if we see that the chaos burn should not be running, yes, this burn is not running, and the CPU utilization should be going down. Now it is around 15% or the 10%. So in this way, this happens, and let's check on the chaos blade, the experiment that we have carried out. So over here, we can write this statement, what exactly we're going to do, what exactly happened at this place. And let's see. Yep. So everything has been executed. Let's see the status. So over here it says success, and the recovery note basically it says destroyed, which means that CPU utilization has been increased and destroyed, and the memory load. So the load, I think some issue had happened, so that's why it's not working. But this has been executed. Let's see in the dashboard. Dipti, I'll just take 2 minutes.
Sure.
So if you guys see it over here, the CPU utilization, we have started execution at around 12:55, and the CPU utilization has been increased. I don't know the reason why the memory has not been triggered. So sorry for that, but this is how we run the experiments in the Chaos Blade tool. So guys, if you have any questions, please let me know. I can answer them now. I think Deepthi, that's it from my side.
Well, thank you, Shravan.